Yeah, hello all. It would be useful for me because I did a slightly similar session yesterday, not on the same topic, but basically taking the same approach, which is looking at a specific JavaScript problem and building a sort of visual framework for interpreting that problem and break it into visuals. Because one of the most difficult things I found when learning JavaScript, and not only when just learning JavaScript, when really trying to become a little bit more proficient in JavaScript, um, one of the biggest problems I found was trying to visualize it. I came from CSS, which was brilliant. I could create nice interfaces and style it, and I would make my change, and visually I would get some sort of feedback for what I was doing, so I could quickly, understand what I was doing, or if something wasn't working, I could quickly see that it wasn't working. JavaScript, that is not how it works. Often you'll only come across the bug quite far down the line, and then you've got to try to figure out where it is. And the only visual feedback you get often is 1,000 console logs. I don't know if anyone on this call has had similar experiences learning JavaScript, but it's a lot of console logging. And yeah, that made it tricky. I did attend one talk which sort of taught me the event queue and the stack, and I could see my functions executing and how each execution ended up with something else on a stack. And again, that gave me something visual, and that's fantastic. I highly recommend it. I should actually find that video. Maybe put the link on here at the end. But my point is just finding a way to abstract away JavaScript into something that your brain can comprehend. And that's what I'm going to show you today. It's really just one approach, an approach that I have. And I started the project really just to help me learn JavaScript. It wasn't really to coach people. It was to help me understand JavaScript, to help me understand concepts. What I was finding was I would learn a concept like the this variable or closures, and I would understand it. Like when I looked it up, I would be like, okay, I know what that is. But then 2 months later, I've forgotten it, and there I am again, googling it, trying to understand it. And by all means, like googling is part of every developer's day-to-day job. That's what we do. We do a lot of googling, but not really like when it comes to concepts and understanding like how JavaScript works. That's not something I wanted to be googling all the time. I didn't want to have to Google what a closure was every single time. I didn't want to have to try and work out what was wrong with my current understanding. Building a mental model, and that's a term that I'm going to use quite often. A mental model for understanding is something we all do, as our brains have to build an understanding of a topic into a mental model. And usually the process for that is a very, very long one of trial and error. So we'll have an understanding of it, we will encounter a problem, and our mental model might not be able to reflect what that, or interpret what that problem is. And then you go through a process of either adding to that mental model, or if there is a current interpretation of that problem and it's flawed or it goes against your current understanding, there's a reworking of that mental model. And that will be a trial and error process that goes on for a very long time. And with JavaScript, it can tend to be quite a long time, depending on your background. Whether you've come from another programming language, it's a lot easier to pick up. But if you've come from HTML and CSS, it can take some time. And I think it's more than okay if you find yourself getting frustrated. It would be useful for me just in the chat, if you let me know sort of where you are with JavaScript, because I'm sure we have a lot of coaches on here who might be quite, they write JavaScript as a job, but there might be others who are still learning, and any the frustrations that you've had with learning the language. Please do interact on the chat. I will just share my screen now. Okay, so Hopefully, yeah, you can see what I'm seeing. So yeah, the session today is going to be visualizing scope. So visualizing scope in JavaScript, and we will be using something that I call the Great Sync. And there's a website here if you wanted to look up more. You can find me on Twitter and Instagram, Kylo Robs or Dev Kylo. A lot of the stuff that I'm going to show you now, usually I would coach either at codebar or on the side in a much longer and more drawn out format where I will go into the specifics. With this session, it might go a little bit quick, especially through the visuals and why I chose visuals. I might not be able to delve too deeply into each image. But there is a lot of information and reasoning behind why I use each image to represent a concept in JavaScript. The code we'll be looking at is something to do with scope. So if we just have a look at this quickly, we've got a variable called count set to 1, a primitive number. If any of you were in my session yesterday, a lot of it was about primitive values versus reference values. The link to that talk will be up on YouTube if you want to catch that. But yeah, we have a primitive value, which is a number, and then we have 2 function declarations, add and new count, and then we have a variable result declared set to what new count that function over there returns. So whatever that returns, which over here is added, that is what is assigned to result. This code, I mean, it's not very complicated code, but the concept of scope really does come out here, because you may have noticed we have var count over here, and then we have another count set to 100 over here. So we have 2 variables called count. And I'm not getting into shadowing. There's a concept called shadowing in JavaScript, where basically you shouldn't be calling the same variable name in different scopes. That's not what the focus is here. My focus is when we interact with count. So over here in this function, we've got count plus plus, which is the same as count equals 1 plus 1. Which count are we referring to? How do we access count? Is it that count or is it that count? And if you know the answer, that's great. But we need to ask why. Why is it like that? Why does this qualify as outer scope and not that? And we're going to break this down step by step so that we can really understand what's going on. So firstly, images. And quick intro to some of the imagery that I've chosen. Some of it is weird and wacky. I do warn you now, very weird and wacky. The reason is, the more original the imagery and the more crazy it is, the easier it is to understand and remember. Sorry, not understand, but the easier it is to remember. I don't know how many car analogies you've come across, but if you're like me, I've come across thousands for explaining things. And yes, they do help to explain a concept. They don't help you remember the concept. So a lot of the images here might be a bit weird. Please just bear with me. There is a reason to the rhyme. So our environment, which is basically the code, when we write our code in somewhere, where does that sit? We are imagining that as an aisle like this, where the water is our code. And it is following gravity. It's flowing from the top to the bottom, and it has to follow that linear progression, top to bottom. And we have a defined environment in which it lives. And we have something over here, which I'll get into in a second, for locating values and things that we use in our code. Often when we write JavaScript, all we're really doing is locating stuff inside of the JavaScript engine and using it. We're locating variables, or we're setting up variables. We are assigning them to values, and both variables and values need to be found. They need to be in an environment that the JavaScript engine can locate and then use in our program. So yeah, that's if you can visualize where all these images that I'll be showing you, that's where they're going to live. Values, I represent as islands, especially the primitive values are all represented by weird natural islands. So they are like the islands we find on our planet Earth. The reason why we use islands to represent values is because they have a set location. They have coordinates. Values in JavaScript are exactly the same thing. They have to live in a specific location in memory. There'll be a specific spot where they live. And the JavaScript engine will use something like coordinates that you would use to find an island on planet Earth. The JavaScript engine would use coordinates to find a value. So the number 1 will have a set location, and the string I am a string or hello world, that will have a set location. And we can have different types of natural islands. So we have, numbers, strings, booleans. There's a few different types of primitive values. But then we also get something that's quite different to a primitive value, like a number. We get something called an object. And an object, you can see, is entirely different to how we visualize what we understand a primitive value to be. An object is constructed. It's not something that's natural. It's constructed. We have to build a ship. All objects and variations of the object in this visual mental model that we're creating together are just going to be types of ship. And inside of that ship, there's a few things that we have. What I want to draw your attention to are these little guys, which are genies. Genies are our way of finding values. So the little genie properties here, because they basically they belong to the captain of the ship. They're the captain's properties. You need to remember the word property. A property will shine down on a value on an island that exists somewhere else. So these are spotlights. So these big spotlights will shine down on any of these islands, and that's the way that an object stores values. We're not putting entire islands inside of the ship, and that's a good way to remember what objects are. That they're not, we often say it's a collection of key value pairs, blah blah blah. That makes it sound like we're putting values inside of objects or values inside of arrays. We don't put values inside. We point to values. So these genies, all their job is to do is to shine the light down on the value when we need it. So if we say object dot, object dot data, then the object and the data property is locating the island, the value that is requested. The important thing to know about objects is that they are invisible. They do not live in the natural world with primitive values. They live in an entirely different dimension. So they are not locatable in our code. So when we write code here, a function, which is also just a type of object, or any other object that we create in our code, we never actually deal with directly. I mean, it feels like we're referencing these functions directly, but just bear with me for a moment and just imagine these functions as completely invisible, and we have no way of interacting with the ships directly. We can't see them. What the JavaScript engine does is give us an island in the natural world that can exist alongside these other primitive values, which has one objective, one sole purpose, and that is to locate these objects and functions and arrays. So they're equipped with a special telescope that can see through, I call it the Heap Multiverse, because objects and functions are kept in a data structure called the heap. And I imagine this heap as a multiverse because it can have multiple objects, multiple functions, unlike primitive values where there's only ever one number 1 or one string called I am a string. There's only one of those in existence in the entire JavaScript engine, because in nature, you can only find one of something. You don't get exact duplicates of things. That's not the same when it comes to objects. Objects, you can have as many objects as you want with exactly the same things inside of them. So it's the Heap Multiverse, and every object comes with what is actually called, what we call in JavaScript, reference values. All right, reference values. So this is the reference to that object, and we use this reference to interact with our objects and functions. So when we write our functions over here and we use it like new count, we are referencing this function. We're not interacting with the ship itself. We are using a little island that points to it. And that becomes really important when we are assigning variables to objects. We're not giving the object to the variable. We're giving the reference island, the pointer to the variable. And you always need to keep track of where is it pointing to. Is it pointing to the object you think it's pointing to? And I do a whole separate session on that. And it comes up in JavaScript all the time, especially in something like inheritance, when you're trying to work out what's pointing at what, or when you're passing objects as parameters and functions. It's something like we had, not a code pen, I just want code. So if we had a function add, and we were passing in an object here, name Kylo, we need to think about this object being a reference, not the ship itself, because the ship is invisible. We're passing in the reference value. We're passing in this little island that points to the object. We're not passing in the ship itself. And one last thing I want to tell you about before we move into scope, which is the point of this discussion, is what are variables? I've talked about genies being in ships as a way to point down to values. Genies are our way of finding values anywhere in our program. If we need a specific number, so if I write 5, we use a genie to go and locate that number 5, because we're essentially asking a question. This is a JavaScript expression. We're asking the JavaScript engine, where is the number 5? And the genie will show us that island. It will go and show us where that island is using the coordinates, the location of that island. But when it comes to variables, all we're essentially doing is assigning that expression or that genie to that island. So if I say var num equals 5, we will have the genie sitting on, and I use a loo. I promise you there is a perfectly valid reason why I have a loo on an island, and I use it for assignment. The first 3 letters of that word being the giveaway. But what we're doing here is assigning a specific genie who we are now giving a name to an island. So those are assignments. So when we look for a variable in our scope, using our mental model, we are looking for a genie. We are looking for where is this genie sitting? Where has num been assigned so we can find that value that he's been assigned to. Okay, I hope you are still with me so far. This is where I do just check that there's like 1,000 questions being like, Kylo, what are you on about? I hope you are still with me. We're getting there. I've now just painted some of the building blocks that we're going to use to understand that scope problem, because we understand references. We now have an image for what objects are. We know they're invisible, but they get a reference island. And we know that we're using islands as the rest of our values, our primitive values. There's one other image I want to show you, and that is a function. Because a function is an object. Yes, we always hear everything in JavaScript is an object, functions are objects, blah, blah. But a function obviously is a lot more than just an object. We can see it's a ship, so immediately we know that this ship flying through the Heap Multiverse is a type of object, and it has some similarities. Notice it has some genies as properties inside of them. So we are able to store values or pointers inside of a function. But we also have a few other things. We have water inside of it. And if you remember when we were looking at our environment over here, which is where our code is running, water represents the code that we write. So we have some code that gets kept inside of the function. We also have this character that comes with every function, and she is the most powerful character in the Great Sync in JavaScript. She is who I call Mage Funk, who essentially has one role, and that is to invoke. She's like a wizard, a sorceress. She invokes spells, she invokes functions. And when she invokes a function, she needs to read out the name of that function. Every function, well, not every function, but if there is a name for the function, she'll read out that name, and she will have an invocation that does some special stuff, and some really special stuff that is key to understanding scope. This is the invocation, and it's almost like a wormhole. We pass things into it. So we will fly a ship carrying genies pointing to other values. These are parameters and arguments that will fly into this void. But I don't want to focus on that. I want to focus on what happens when a function gets invoked. So if we have, function add, and we had return 1 plus 1, and sorry, I'm not using a code editor, so this looks horrendous, but just forgive me. And then we invoke it like that, our parentheses being our image for this big wormhole that gets opened. As soon as we do that, as soon as we invoke that function, we get an entire new execution context. Now we're getting into the juicy stuff. So we get an entirely new execution context. What is that word? It's a strange word. It's our environment. So we get another one of these. Remember I showed you, like that's where our code is running, and that's, our code is running in that. But as soon as we got an invocation, as soon as we ran the function, this was created, and we get more code. And what is this code that's running? Well, it's the code that we had inside of our function, return 1 plus 1. That's the same as the code that is actually inside of the function itself. It's stored there. And then when we get a whole new execution context, we get to use that code inside of it. And it will start flowing from top to bottom, following gravity, until it eventually returns something off the edge. Every function returns something. Whether you save return or not, something has to go over the fall. It's gravity. It's flowing from top to bottom. Where's it going to go? It will return something. Sometimes it will return undefined if you don't explicitly say what it returns, but it will return something. Inside of this execution context, we get something I haven't specifically talked about yet, and that is a light scope. So it's like a lighthouse. You may have noticed the theme of pointing, shining down, being a recurring theme in the Great Sync, because that is what you do. You point at values, and when you look for variables, so when you search for specific genies, the light scope is what's used to locate the genie. This light scope is not only just a pointer, it's a memory location. It's local storage for that environment, that execution environment. You can see the little squares that I have here. You can imagine that as literally just a package that has the name of the genie that lives inside of its environment and the location of it, because it's got to have a location. Every island has to have coordinates, and it might have a whole lot of these boxes. It might only have one. It might have 0. But it will store the names of genies, and then when we look for a genie, so we look for the genie called data, the variable called data, the first thing the scope does is search its environment. So it looks inside using the coordinates inside of the, what it has stored, and it locates it and shines a light down. And as soon as we have it, we can use it in our program. If we can't find it, it will shine on undefined. It's inaccessible, can't find it. And there, we are almost there before we can finally look at our code example and break it down. There is one more thing we get with this execution context that gets created every time we invoke a function. So I've mentioned we get the code that runs, we get the scope, we get the storage. We also get a this variable, by the way. That's also something that comes with it. But there's one last thing that's really key to understanding scope that it gets. And we visualize that as a sphere. This orb, and I like to think of this as like a, like a looking sphere, like, like the witches would all bend over this orb, and you could look inside of it and see another world somewhere else, very random, whether you understand it or not. It is just a window into another environment, into another scope. It's like a looking glass. It's a way of seeing into another one of these that isn't its own. Why does it have one of these? And by the way, it will just float near the scope. So if this light scope can't find it, it's always there for it to look into. Why does it have that? Because every function has access to its outer scope. So function add, if we had a variable here called data equals 1, and we returned, rather than 1 plus 1, we returned data plus 1, the code inside here we know is represented by the code inside of the execution context. So if it needs to find the genie called data, we know that the data genie isn't inside this context. It's not there. It's in the outer scope. And the outer scope is this little window that we use to look into that outer scope. But here's the thing. This is the pivotal concept behind scope, and what can be really confusing about scope is what is the outer environment. If I had a function here, function init, right? And I added this function inside of that, and I'm not going to bother with formatting, and forgive me for not using a proper code editor. It's just for the moment while I show you small examples. But here we've got a function now that's defined inside of another function. So what is the outer scope now? Is the outer scope this function? Or is the outer scope the global scope? And if I were to change where add was, would that change it? What is outer scope? I just go back to our original example. Our way, using our mental model, of understanding what outer scope is understanding where this function lives. So function add is a ship, right? Which has a reference value. It's that ship, that function, which will create this execution context. So when we need to look at its outer scope, when we need to look inside of its sphere, we are looking at the environment which gave birth to that sphere. So we look at the scope where that function value exists, and we then have access to everything inside of it. Now, I know that's going to sound like very vague and not clear. So this is where I'm going to show you step by step an example of the code that we had and break it down. But if you can just try and remember that the scope, whenever you see the scope over here, we are thinking about the environment where the function that executed to create this execution context, that the actual function value, which is the ship and the reference floating around, what is the environment, the scope that that function lives in? Because it's that scope that it has access and is able to locate variables that it might be looking in. So let's go more specific. Let's just start with this example here. So I've got a variable called global var saying I'm down here. We've got a function called inner function that's called over there. We've got another function called do something. Okay, let's actually for the moment remove that because we're calling it over here. So we've got an inner function called over there. When we're inside of inner function, we can see function do something that gets defined, and then we get do something being called. So what does that look like using our mental model? So I'm going to go line by line and build up an image of our code. So we have on our first line over here, line 8, a variable declaration. So we're getting a genie called global var, and it's pointing to a string value. This, to begin with, is inside of an environment, an execution context. All code has to run within an execution context. So already we have a defined environment, we have our water, and we have our scope for locating genies. When the first line runs, we create that island. So there is our island, global var, called I'm down here. So we've got our value. The second line runs, and we've got a function declaration. Notice we're not invoking the function or anything like that yet, so we're not even bothering with what's inside of it, because we're just creating a function that has some code in it. We're not doing anything with that code. So we go and create our function, and we get two things. Remember, we get our reference, and then we get this invisible ship that we will just make visible for our purposes. But we get a ship called inner function. Then we get an execution. So we have Mage, our sorceress, who will then descend down and invoke the function. And before it, I am missing one line of code here. This should be var result equals. So we are setting up another genie called result, and we execute the function. We know as soon as we execute a function, we're getting a whole new execution context. So boom, we get a whole new execution context with water, our scope, and a reference to the outer scope. When this runs, we declare another function. Not running it, just creating another function, another ship. So let's go and do that. We go and create our reference island and a new ship. And the next line is we execute that. So we go and execute. There's our execution. Oh, not that one. This one. There's our execution. So the sorceress made trunk who lives on every function has now executed, created this like wormhole where we can pass things like arguments and parameters. And as soon as we do that, we know we get a whole new execution context, don't we? I know I've said that too many times today, but boom, there we go. And of course, we get a light scope, a way of accessing genies that are inside of it. But this is called the creation phase. Code hasn't run yet. We're not getting any water that's cascading down. We're just forming the environment where our code is going to run. And part of that is getting a light scope and access to its outer environment. At this point, we have some console logs. So technically, this is another function. So this would just create another execution context because it's a function. But we're doing something else. We are referencing global var. So now we are actually asking, where is a specific genie? So the light scope will immediately activate, inside of our JavaScript engine. It'll be like, okay, we need to find genie called global var, and it will search its realm and search its records, and there will be no global var. Like, it'll be like, oh no, can't find global var. Should I return undefined? And then it won't, because it will remember that it has access to something else. It has access to this magical orb that is sort of hovering around it like a planet orbiting it, however you want to picture it. But it's there. It has access to it. It's a window. It can look inside of it. But where does this look into? Does it look into here? Or does it look into here? And that is the eternal outer scope question in function. When you have nested scopes as a developer, it gets confusing as to what is outer scope. Is it that, or is it that? Or is it maybe you have 10 of these? You have 10 different functions that are running, which is its scope. But our way of remembering what is outer scope is thinking about what gave birth to this entire execution context, because we know that these are only formed one way, and that is by a function that is invoked. So here is the function that it was invoked. So that function was invoked, and that's what gave birth to it. So this is access to, if you look inside of it, you can see the whole realm. You can see everything that's inside of it. What is the function that was invoked? It is called do something. And do something is here. There's our reference value, and it is actually pointing to that function. So this is the environment that it lives in. So this scope now will suddenly look for the genie called global var, and it will search, where is global var? Can't find global var, it's not in my records. What do I have? Oh yes, I have access to my outer scope. What is the outer scope? The outer scope is the function, the environment where the function that gave birth to this whole execution context. What gave birth to this? Well, it's execution, but it's not to do with the execution. It's to do with the function. Because if I were to execute this somewhere else, if I were to execute it inside of another function, that's not the environment. It's got nothing to do with the where we invoke that function. It's got everything to do with where the function value exists. So there's this inner function which created this execution context, and now we can see the whole environment. And this light scope gets activated, and it says, hey, there's a global var, there's the genie, and that's how we're all the way up there, we're able to use global var. We console logged it, but we could do anything we wanted. But there is a chain of reasoning for why we were able to access global var. Right. I need to quickly now go to the actual example that I started with, that we are meant to be focusing on and not getting too caught up in this. I even told myself, Kylo, don't get too caught up in this, and that's exactly what I did. The example that we want to look at, and this is where I quickly check if we have any questions. And yeah, okay, we're good. This is the example I started with. So we have a variable called count, and let's go to our canvas to start building up our image, our understanding of that. So before we even run that code, we know we have an environment and we have scope. We have to have that. When code runs, it has to have this environment. The first line that runs is a variable declaration, setting it to 1. So let's go and do that. We go and add our island. Got him. We have our number island called count, and we have a genie called count. I didn't bother putting the actual genies in this image because it was just going to be a lot more work for me, but you can imagine a genie sitting on that island sunbathing. The next line we have is function add. So function add gets created, and boom, we get our ship and we get our reference value. Notice we are not even bothering with what the code is doing there, because at this point in time, that's really irrelevant. All that is for us is just some water that's kept inside of the ship value, function value. It's there, that we don't really need to know what it is. Cool. So yeah, that's looking good so far. We understand what the two values we have. We've got another value called new count, function new count. So it's a function value. And with every function, we know we're getting yet another reference and yet another invisible ship that is not invisible in Adobe Illustrator. We've got that, and we're not bothering with this code because that's the water inside of it. And we've got a variable result that is declared and assigned. So there's our genie, and it's assigned to this invocation. So new count, which is this function, has a mage. There she is. And her job is to invoke the function. So she will come down to here and she will execute and create this wormhole that actually stops gravity. That's how powerful it is. So all the code that's flowing from top to bottom suddenly just gets pulled back. And that's how synchronous JavaScript works. Your code won't continue until this execution context, this wormhole, has closed, and it will only close when that water from the new execution context that gets created like that, as soon as that water disappears and this turns to dust. And then everything goes back to normal and water flows off the edge. But that's not where we are now. All we have is this execution context and a new environment. So we have water and we have scope. Cool. So the first line inside of new count is declaring, hang on a minute, another count. So there's a count there and there's a count there. So I go and declare count. Count 100. So we have a genie sitting in there. The genie goes inside of the local store, of the local memory of this environment, and it gets stored, cataloged, named, and coordinates recorded just for the genie and where he lives. So we can always find them inside of this environment. We then have a const added equals. Equals, we know, is an assignment. Let's go and add that. Const added equals, and we have an invocation, add. So immediately when we use add, that's the same as just writing a variable name inside of an environment. You're asking where add is. Where is add? So we go to the light scope and we say, where is add? We need to use add because we need mage func to come and invoke the function for us. We need your sorceress, otherwise we can't actually continue this code, but we need add. We need to find the function add. And the light scope looks inside of its environment and it says, we ain't got no add. There is no add here, but lucky for you, we do have access to something that only I have, direct access to. I can look into this window, this magical window into a realm that is what gave birth to this entire environment. And what was that? It was the executing of new count. Remember in our code over here, new count, which is this execution. Well, new count is that function, and we need to find where that function lives. That's what this window looks into, the environment, everything around it of that function. And there, lo and behold, is add. So the light scope there says, oh, okay, all good, we've got add. And over here, added is able to execute. Boom. And what happens when we execute? I'm sure that you are so tired of me saying this, but we get a new execution context and we get our light scope and our ability to see into the outer scope. And what happens in here? Well, let's have a look at our code. We are returning count plus plus. Ooh, count. We're referencing a value. We're asking, where is the genie? Count. Where is count? Well, the light scope looks inside and it says there's definitely no count inside here. Let me look inside of my outer scope. What is the outer scope? Where is the function that created this? The function that created this is called add. So add, then if we look at where that execution context is, we look inside there and it's like, okay, add is down here. There's the function. So the function called add lives in this entire environment. And it's that environment that we have access to. So when we look for count, it's like, oh, there it is. There's count. We've got count. So count over here is 1, 1 plus 1. Where everyone goes wrong, no, that is a complete lie. Not where everyone goes wrong, where a lot of people go wrong, where I went wrong when I was learning, and where you won't go wrong after remembering this whole crazy chaotic scene that I painted for you, is that the count over here, 100, is not the outer scope. So there's our 100. And when we were in this scope and we were asking where count is, we don't just look to the next execution context or the next executing function inside of the stack. You know, I was talking about the stack when we started this, and we can see each function just like this, really. It's just a stack of functions that have been executed. But we're not looking at where the function was executed. That's not what's important here. So we're saying add, there's our add over here. We're not looking at this execution context. So this count isn't relevant at all. That's not where this looking glass looks into. It's looking into this environment over here. And that's how we're able to find count. I wish I had more time to sort of go through this and explain it in a less chaotic manner. But I would love to hear actually if you guys if you found it useful, interesting, confusing, or if there's something that can be gained from creating visuals like this, breaking JavaScript down, because I found it personally enormously helpful to think line by line what is happening in my mental model, my understanding of JavaScript. Why can count not be accessed here? Even though I can see my code editor grays it out, so I know that that's not what's being used here. I still need to understand why it's being grayed out. And this is what helped me, and I hope it helped you. If you are interested in more of the Great Sync, as I said, there's a website, thegreatsync.com, and you can email me, and I'm a coach at Codebar, so you'll see me around there. But I hope you found that useful.